let's return to our initial example where we have 5x minus 3 divided by x squared minus 2x minus 3. And we just solved this problem, so we kind of know how to create the partial fractions in this case. But let's imagine that we don't. What would our setup be? Well, the first thing that we have to assume is, indeed, we can factor this denominator. Okay? So we'll just assume we can do that, and we assume that you've gone along and done that using whatever method you want to use, and we get x plus 1, and we're going to say plus x minus 3, like this. And in the typical problem, we would not know what the numerators are. But if we pick these numerators correctly, then this sum over here will be equal to this fraction. Now, the reason these things are called partial fractions is because their denominators form elements or parts of this denominator. Okay, so how are we going to go about solving for a and b? Well, the first thing we could do is, instead of writing this out as a polynomial like this, let's write it out as x plus 1, x minus 3, like that. And then what I want to do is multiply through by this term. Okay? So I'm just going to multiply both sides of this equation by the factor x plus 1, x minus 3. Over here, x plus 1, x minus 3. And here I'm going to multiply this by x plus 1, x minus 3. Okay? So what's going to happen? Well, in the first term, the denominator totally cancels with what we are multiplying through by, and we get 5x minus 3. All right. In this term, when we multiply by this cancels with this, and we get equals a, our unknown, times x minus 3, plus over here we get this cancels with this, and we get a b term, x plus 1. Now, okay, now I want to rewrite this a little bit and group the terms differently. So we still have 5x minus 3 is equal to, and now I'll a times x and b times x, so we get x times the quantity a plus b, and then I've got a minus 3a, and I've got a plus b, something like that. Now, if you look at this, the way we're going to proceed is by noting that this coefficient, the a plus b, has to be equal to 5, because this is times x and this is times x. This side has to be equal to that, and this term here is going to have to be equal to that. So what we can do is rewrite our thing to say a plus b equals 5, and minus 3a plus b is equal to minus 3. So we have two simultaneous equations and two unknowns, so we can solve them. And one of the ways we could do it is just by subtraction. Let's subtract this equation from this equation. So minus a minus 3x, we get plus 3x plus a minus 3a minus becomes a plus a, we get 4a. Minus b plus b, we get nothing, equals minus a minus 3, and we get 8. Therefore, a is equal to 2. If a is equal to 2, then we can come back up to this equation and say 2 plus b equals 5. Therefore, b equals 3. So that when we go back up here, we can now substitute in 2 and 3, and we're done. We've now got our partial fractions, and we can go and use a little bit of baby calculus and figure out the answer.